Hi friends, today I am going to discuss about the basic character in amines. Amines are basic in nature. Why? Because amines are the derivatives of ammonia. RNH2 is the general formula of primary amine which has a lone pair over nitrogen and which is available for donating. So that amines are basic in nature. RNH2 is primary amine, R2NH is secondary and R3N is tertiary amine. In all these three amines, nitrogen is in a position to donate its lone pair. So that amines are basic. And today I am going to compare the basic character between different types of amines. So let's compare first between alkyl amines, ammonia and aryl amines. As I told you, alkyl amines are RNH2, ammonia is NH3 and aryl amine is AR. ARNH2 means amino group is attached with an aryl group or a benzene ring. In alkylamine, first we will have a comparison between alkylamine and ammonia. In alkylamine, RNH2, this alkyl group shows plus I effect. Plus I effect represents electron releasing effect. So that this alkyl group releases its electrons to the nitrogen atom. So that overall electron density of the nitrogen increases. So that in turn, that will be increasing the basic character. Because basic character means it is the ability to donate electron. As because of electron density increases, the basic character is also increases. But in ammonia there is no alkyl group. So that the basic character will not be having any effect. So when you compare alkylamine and ammonia, alkylamines are more basic than ammonia because of the plus I effect of alkyl group. Now let's have a comparison between ammonia and arylamine. Arylamine is the one in which amino group is attached with NH2, benzene with the NH2. And here I have drawn the resonating structures of aniline. If NH2 group is attached with the benzene ring, due to resonance, the lone pairs of nitrogen will be moving towards the benzene ring. We know that as basic character increases because of the electron density. But here, electron density is moving towards the benzene ring. So that overall electron density decreases. So that basic character also decreases. Noted? So electron density of nitrogen decreases in aniline due to resonance, so that basic character of aniline decreases. This is one of the major reasons. One more reason is there, that is due to instability of anilinium ion. Anilinium ion, I'll tell you first. If aniline combines with a proton, why I'm telling about the combination of proton? Because the definition of a base is the one which accepts a proton. So when aniline combines with a proton, if it is acting as a base, it changes to NH3+, benzene with the NH3+. This is called the anilinium ion. And this anilinium ion resonating structures are these two. Just by changing the position of double bond, we are getting two resonating structures. But in aniline, here I have drawn 5 resonating structures are there. As the number of resonating structures increases, stability also increases. So because of that, we can say that aniline is more stable than anilinium ion. Anilinium ion is less stable. Why? Because it has only 2 resonating structures. So from a more stable species to less stable species, this reaction will not be taking place easily. We can say that this is less feasible. It's not a feasible reaction, it's less feasible. So that this reaction will not be taking place easily, or the acceptance of the proton will be difficult in aniline. As it is difficult to accept a proton, we can say that it is less basic. So these are the two reasons why arylamines are less basic than ammonia as well as alkylamine. So when you have a question in that all the three species like alkyl, aryl and ammonia are there, always you select alkylamines are the one with the most basic character and arylamines are the one with the least basic character. Ammonia is always coming in between these two amines. So that's the first comparison. Now let's have a second comparison between different alkyl amines like primary, secondary and tertiary. For that, first I am going to take about gaseous phase, because amines can exist in two different phases like gaseous phase and aqueous phase. In gaseous phase, plus I effect is the factor which determines the basic character. Let's take different amines like primary amine RNH2, this is primary. Secondary is R2NH. Now tertiary is R3N. These are the three amines: primary, secondary and tertiary. Here we can see that from primary to tertiary, alkyl group numbers are increasing. There are three alkyl groups in tertiary. So that overall plus I effect increases. Because of plus I effect, electron density of nitrogen increases. Why? Because plus I effect is the ability to release the electrons by the alkyl group. All the three alkyl groups are releasing electrons to the nitrogen atom. Overall electron density increases. So basic character also increases. So we can say that tertiary amine is most basic, which is more basic than secondary than primary. So this is the overall basic character order between different amines in gaseous phase. But in aqueous phase, comparison number 3. In aqueous phase, there are two factors. Number one is plus I effect. Plus I effect is one of the predominant factor. But according to plus I effect, here I have discussed tertiary is more than that of secondary than primary. But there is one more effect which is called the solvate effect. But in aqueous phase, gaseous phase, there is only one effect which determines the basic character. In aqueous phase, there are two factors which determines the basic character. One is plus I effect, another one is solvate effect. So what is solvate effect? It is the ability to form hydrogen bonds by protonated amine. So how much is the protonated amine to form the hydrogen bonds? That ability is called that effect is called a solvate effect. So what is protonated amine? I'll tell you. If I take a primary amine which is RNH2, when it attacks with the proton, we get RNH3 plus. This is the primary protonated amine. So protonated amine means when an amine attacks with the proton, the resulting product. Similarly, secondary amine R2NH plus H plus, we get R2NH2 plus. This is secondary protonated amine. And finally R3N, tertiary amine with the proton, we get R3NH plus. This is tertiary protonated amine. And in these three cases, when you compare, number of hydrogen atoms are more in primary. There are 3. Secondary only 2. But in tertiary only 1. As the number of hydrogen atoms increases, ability to form hydrogen bonds also increases. So as the number of hydrogen bonds increases, basic character increases. That's a concept. So as because of more number of hydrogen bonds, we can say that primary is more basic than secondary than tertiary. But in plus I effect, we told the reverse effect, like reverse order. Tertiary is maximum. But in solvate effect, primary is maximum. So both the orders are opposite to each other. So that to make the final or overall order, we take the secondary. Secondary amine is the one with the most basic character. After secondary amine, we go for tertiary and then primary. This order is applicable for all amines except methylamine, all the higher amines. But for methylamine, you take secondary after primary and then tertiary. This is only for CH3NH2. So in board exams and all, when you get a question to compare the basic character between different amines, if the phase is not mentioned, always you have to write the order according to the aqueous phase. But if it is gaseous phase, the phase will be mentioned in the question. And if it is aqueous phase, you check the type of amine. If it is methylamine, always you go for this order: secondary, then primary, and then tertiary. Secondary, primary, tertiary. But if any other amine, normally methyl and ethyl amines only will be coming in questions. If it is ethyl amine, you go for secondary, after tertiary, and then primary. This is how you have to arrange the basic character between different types of amines. Okay, so I hope you understood that. Now let's have a comparison between different types of substituted aniline. Aniline is the one in which NH2 group is attached with the benzene ring. But that aniline is having some substituents in the form of CH3 or OCH3. Or sometime that can be having NO2, SO3H or COOH, like that any group. All these groups are electron withdrawing groups, and these groups are electron releasing groups. So if there is an electron releasing group like CH3 is there, it releases electrons to the benzene. So benzene will be giving electron to the nitrogen. So that kind of direction. Because of that, overall electron density of nitrogen increases, basic character also increases. Got it? But if there is electron withdrawing group like NO2, it pulls the electron from the benzene. So benzene will be pulling electron from the nitrogen. So that electron density decreases, basic character decreases. So we can conclude like this: if there is electron releasing group, it increases the basic character, but withdrawing group is there, it decreases the basic character. Okay, so these are the four comparisons. So once more, like if you have a question, always you check alkyl, ammonia and aryl amine, and alkyl first followed by ammonia and then aryl. But if different amines are there among alkyl or among aryl, always you go for aqueous phase if the phase is not mentioned, like secondary most and then tertiary then primary. Only for methyl amine, secondary, primary and tertiary. But gaseous phase, tertiary, secondary and primary. And substituted aniline according to the electron releasing or withdrawing groups you can arrange. So let's discuss some questions to understand more about this, like C6H5NH2, C2H5NH2, C2H5 twice NH and NH3. C6H5 is completely an aryl amine. C2H5NH2 is an alkyl amine. C2H5 twice NH is alkyl only, but it is secondary amine. But the second compound is a primary amine, and then last compound is ammonia. So when you select the basic character order, if it is increasing, you select always alkyl amine. But among alkyl amine, as I told you, if the phase is not mentioned, go for aqueous phase. In that, secondary is most. So C2H5 twice NH comes in the right side. That greater than primary. There is no tertiary here, so primary. If tertiary is there, you have to write tertiary after this. Then ammonia. After ammonia only you have to write the aryl amine. So this is the answer. Now in the second question, C2H5NH2 which is alkyl primary, C6H5NH2 is aryl, ammonia, C6H5CH2NH2. Here you can see an aromatic ring as well as NH2 group, but NH2 is not directly attached with the C6H5. It is attached with another carbon through another carbon. So we can say that it's partially aromatic and partially aliphatic. It means its basic character comes above completely aromatic compound. The last one is alkyl only, but secondary. So we can arrange like this: C2H5 twice NH, that is secondary. After that primary, C2H5NH2. So all alkyl amine done. Now ammonia. After ammonia you have to write the partial aliphatic and aromatic amine, which is C6H5CH2NH2. And then C6H5NH2, the one with the complete aromatic property. In the next question, this is alkyl primary, alkyl secondary, this is alkyl tertiary, and this is aromatic. So I'm just putting the numbers now. Secondary first, then tertiary, then primary, and then aromatic. This is how we can arrange. OH. Now 2-3 questions more. CH3NH2, which is aliphatic only but primary. This is aliphatic secondary. This is aliphatic tertiary. This is aromatic. This is half alkyl and half aryl. And this is methylamine, so always you go for the aqueous phase only, but still after secondary you have to write primary, not tertiary. Then tertiary comes as a third position, then half alkyl, half aryl, and then only complete aromatic. Okay. And finally, aniline. Aniline is the one with the NH2 alone in the benzene ring, but para-nitroaniline means NH2 is there, but in the para position NO2 group is also there. Para-nitrotoluidine means aniline with CH3 group in the para position. As because of CH3 group, it acts as electron releasing group. It increases the basic character. But NO2 group is electron withdrawing group, which decreases the basic character. Releasing group is increasing. So the basic character order is, this is 1. After that you have to write aniline, the one without having any of these. And finally it is with a NO2. And the last question, which is in gaseous phase. In gaseous phase I told you tertiary, then secondary, then primary. So tertiary is this, number 1 secondary, this is primary, third position, and finally ammonia, fourth. Okay, so this is how we can arrange the basic character between different amines. So when you study, if you follow this kind of different comparison, it will be easy for you to attend the board exam. Thank you all.